Hey, Jody here, weldingtipsandtricks.com. Today's video is about dual shield flux core welding, where you use a flux core wire as well as a shielding gas. Let's get right into it. I'm going to go ahead and get right into some welding here today. This is just a 2F T-joint, and later on in the video, toward the end, we'll talk about some of the details. No real manipulation of the electrode is required on running stringer beads like this, just a straight up drag with a drag angle. There's an old saying, if it's got slag, you drag, and that kind of applies here. I'm not saying you can't push it, but to do it per the book, you need to drag it when you have dual shield flux core, as well as self-shielded flux core. But with welding, it seems to be an exception to every rule. So, if you get in a spot where you have to push instead of drag, as long as you keep that flux behind you, you can be okay. I placed that second bead about 2/3 over the first bead, and that just leaves a nice little groove for me to follow the edge of that weld just straight up and just, try to make a fairly even fillet weld that's stacked nice and evenly, where this bead is just about halfway over the previous bead. And now I'm going to go over really quickly some things that are important when you're dealing with gas shielded flux core. Drive rollers, contact tip and extension, nozzle dip, polarity, shielding gas, and the stick out, also known as CTWT or contact tip to work distance, and then your settings like voltage and wire feed speed. Flux core wire is hollow. The flux is in the middle, so it's hollow and can be crushed. So if you have to use a lot of tension on the tensioners, you can crush it and have feeding problems. So knurled rollers that are the right size are the way to go. You can use less tension and still push the wire through the liner. This particular wire recommends 3/4 of an inch stick out. So I've got to have my contact tip roughly flush with the nozzle in order to get that in a T-joint. And so that's why I have this thing just about flush or slightly sticking out. Nozzle dip, is it necessary? It helps a lot. And if you're in a pinch, you can definitely get by with some Vaseline. And no MSDS required for something that you can rub on a baby's butt. So there you go. Polarity. In this particular wire, it's recommended DC electrode positive. So I've got the ground clamp hooked up to the negative. C25 gas, that's 7525 argon CO2 gas, roughly 25 to 30 CFH. This particular wire can be run with straight CO2 or an argon CO2 mix. Let's talk about settings for a minute. Where do you go to find a good starting point for settings? In this particular machine that I was using today, there's a chart on the inside of the door like a lot of welders have, and it's got an error on it. It's calling out DC straight polarity for E71T-1. That's wrong. It needs DC reverse polarity, electrode positive. So you can't always rely on charts. A much better resource that I found was this. It's called the Procedure Handbook of Welding from the James F. Lincoln Foundation. And it's got a section in there for gas shielded flux core, and it's much more accurate settings. I'll show you that in just a minute. The reason it's more accurate is because it's got separate charts for separate positions. As you can see right here, it says this one's written for overhead as well as vertical uphill. Now this particular chart's written with CO2 shielding gas in mind. Just know you're going to use slightly less voltage with an argon CO2 mix. Plate thickness 1/4 inch and up, 1 or more passes. Electrode class E71T-1. That's key. Different brand names can have different proprietary names, but this is the class. Then I'm using 045 wire, that's 1.1 millimeter wire. Wire feed speed 275 to 340. That's a decent narrow range. I've seen some charts that say 200 to 800. That doesn't really help me a lot. Current, DC plus, the electrode positive polarity, very important. See, the chart on the machine was wrong. Voltage 25 to 27, and since this chart is for CO2, I know I'm going to need a little less voltage than that for the argon CO2 mixed gas. The stick out 3/4 of an inch, and then for vertical up, a slight push angle of 5 degrees, or if I'm doing overhead, a drag angle of 50 degrees. All right, so I like to tell everybody about this because it's such a good deal. It's $30 right now from jflf.org. A comparable book like this from the American Welding Society would be as much as $200, maybe even more. Now, a little side note here, it's not going to help you if you live outside the U.S. because shipping will just kill you. But if you're inside the U.S. and you want a great little book for parameters for flux core and MIG and all that stuff, this is a great book. Well, that about wraps it up. I appreciate you spending time on my channel. See you next time.